Today we're going to be talking about hyperbolas. A hyperbola is the set of all points in the plane where the difference of their distances from two fixed points called the foci is constant. The segment joining the two vertices is the transverse axis of the hyperbola, so that would be this segment right there on our graph. The asymptotes are lines that the hyperbola approaches for large values of x and y, and specifically when we're talking about hyperbolas, we are dealing with slant asymptotes that run diagonally instead of vertically or horizontally. The standard form of the equation of a hyperbola with center at 0, 0 and transverse axis on the x-axis is given by the equation x squared over a squared minus y squared over b squared is equal to 1 that has the following characteristics. The length of the transverse axis is 2a. The coordinates of the vertices are plus or minus a, comma 0. The length of the conjugate axis is 2b. The coordinates of the covertices are 0, comma plus or minus b. The distance between the foci is 2c, where c squared is equal to a squared plus b squared. The coordinates of the foci are plus or minus c, comma 0. And lastly, the equations of the asymptotes are y equals plus or minus b over a times x. And to reiterate, these are slant asymptotes. Below you'll find the case and the characteristics for the hyperbola that has the transverse axis on the, that's a typo there, that should say y-axis, and it's given by that equation there. So here we have the graph of two different hyperbolas here, and below that we have the directions on how to sketch a hyperbola. So the first step is to sketch the central box. This is the rectangle centered at the origin with sides parallel to the axes that cresses on axis at plus or minus a and the other at plus or minus b. Then the second step is to sketch the asymptotes. These are the lines obtained by extending the diagonals of the central box. So notice that we get the slant asymptotes by connecting the opposite corners of our box here. Then we want to plot the vertices. These are the two x-intercepts or the y-intercepts. So I'll highlight on the left-hand graph, this is one of our vertices here, and then that's another one highlighted there on the right-hand side. Then finally, we want to sketch the hyperbola. Start at a vertex and sketch a branch of the hyperbola approaching the asymptotes, then sketch the other branch in the same way. So we'd start here at a vertex and kind of extend so that it gets close to the slant asymptote, and then we'd do the same thing on the other side. So let's go ahead and jump into an example of graphing a hyperbola. Example 3 asks us to find the vertices, foci, and asymptotes and sketch the graph. Check your answer using a graphing calculator, and we have the equation 9x squared minus 4y squared equals 36. So this is not in standard form as we have it. So what we want to do is we want to divide both sides of the equation by 36. And so that will give us 9x squared over 36 minus 4y squared over 36 is equal to 1. And then we can go ahead and simplify the fractions on the left-hand side of the equation. And that's going to look like x squared over 4 minus y squared over 6 equals 1. Sorry, that should be a 9, not a 6. And we know that since the x squared term is first, if we go back up here, since the x squared term is first, that tells us that the transverse axis is on the x-axis. So our graph is going to look something like this. Okay, so this is in the form x squared over a squared minus y squared over b squared is equal to 1. So if we have a squared is equal to 4, and we take the square root of both sides, we end up getting that a equals plus or minus 2, and b squared is equal to 9. So if we take the square root of both sides, we get b is equal to plus or minus 3. Now, we know that our vertices lie on the transverse axis, and so our vertices are going to be at plus or minus 2, 0, and then our co-vertices are going to lie at 0, plus or minus 3. So I'm going to go ahead and plot those. Here's my y-axis, here's my x-axis, and my vertices are at 2, 0, and negative 2, 0, and then my co-vertices are at 0, 3, and 0, negative 3. And now that I have that information, I can go ahead and plot the box that is being referenced in step 1 of graphing a hyperbola. So basically the way that we graph the central box is by connecting the vertices and the co-vertices like this. So notice that I'm using a dashed line since that's not officially part of our graph. So I'm using a dashed line instead of a solid line. And then from here, the next step in graphing our hyperbola is to sketch the asymptotes. And recall I said earlier, we get the asymptotes by connecting the opposite corners of our box. So I'm going to highlight this corner, and then I can connect those with a line. Again, this is not officially part of my graph, so I'm going to use a dashed line instead of a solid line. And I also want to make sure that my asymptote is also going through the center of the box, which in this example is at the origin. Okay. So I'm going to highlight the corners of the box there, and then use a dashed line to draw my asymptote there. Now, let's see. So we have identified the vertices. We need to find the equation of the asymptotes. And so I don't memorize the formula for the asymptotes, and I don't recommend that you do either, because it's either going to be plus or minus a over b times x or plus or minus b over a times x. But we can actually see the equations of the asymptotes from the graph by doing rise over run. So if I'm starting here at the origin, and then I count up 1, 2, 3, and then over 2, that's going to tell me that the slope of that line is 3 over 2x, and then the other asymptote has a negative slope, so it's going to be negative 3 over 2x. So these are my two asymptotes. Here are my vertices and co-vertices. So I've located the asymptotes now. And then we've gone ahead and plotted the vertices. So there's a vertex here and a vertex here. And then the last step is to create the graph that's then going through the vertices and also hugging the asymptotes. So the solid green part curve is the actual graph for the hyperbola. So those are where the solutions lie, those ordered pairs on the solid green part of the graph, and the rest is just structure to help us graph this. And then lastly, we still need to find our foci, and we're going to use the equation c squared is equal to a squared plus b squared. And we know our a squared value is 4, and our b squared value is 9. So we end up getting that c squared is equal to 13, and then we can take the square root of both sides and get c equals plus or minus the square root of 13. And we know that our foci are located on the transverse axis, which is the x-axis. So that's going to tell us that our foci are at plus or minus the square root of 13, comma 0. But for more practical purposes, it might be helpful to change that into a decimal. So this is approximately plus or minus 3.6056, comma 0. And so those are going to be about here and here. Maybe I'll just label them F1 and F2 for focus 1 and focus 2. So that we can call that one F2, and then that point there is F sub 1. So we've also found our foci. And if you'd like, you can definitely graph this on Desmos to verify that this is, in fact, the correct graph.